Hey guys, welcome back. So the objective of this video is to continue on from the last video where we will now talk about the continuity correction. So from the last video, we introduced a variable called xSum, where we will now change the variable into x, right, for a notation change, for the convenience of notation. And so we said that x denotes the number of successes that we are interested in, and that x belongs to a binomial distribution of NP, where n denotes the number of trials that we have performed, and p denotes the probability of success. And so by the central limiting theorem, x is approximately described by the normal distribution of a mean of n times p and a variance of n times p times 1 minus p. So this approximation here is true due to the central limiting theorem. And remember, x denotes the number of successes. And so let's say we're interested into finding the probability that the number of successes is less than or equal to I. Or we want to find the probability that we have I amount of successes. So there are two methods into finding these two probability values. So the first method is to use the binomial distribution formula. Okay, so what I mean by that is this formula here, which was introduced in the last few videos. Okay, so we know that x, the number of successes, the variable itself belongs to a binomial distribution NP, and so therefore we could find these two probability values by using this formula here. Okay, so this is what I mean by binomial distribution formula. So the second method we could find these two probability values is by using a normal approximation, okay, to the binomial distribution. So we could say that x is approximately described by the normal distribution of NP and NP 1 minus p, alright? And then we can find the probability by standardizing this normal distribution into n01, and then afterwards we can then use a table to find these two probability values, okay? So basically using this table, okay, this table carries all the probability values, okay, which will help us to determine these probability values, okay? So if you guys remember that at the beginning, right, in a binomial distribution, x being a binomial random variable, right, can only take integer values, okay? So we know that a binomial random variable is an example of a discrete random variable, and so discrete random variable can only take certain types of values, which in our case, the binomial case, can only take the integer values. Okay, and so we know that the probability that x, a binomial variable, is equal to a certain integer value, 3, right? It must not equal 0, right? This probability must not equal 0. Okay, so if you look at this formula here, okay, of a binomial distribution formula, okay. So this here, when you sub in the values for n and I and p, right, into the calculator, okay, this formula into the calculator, you would get a non-zero value. Okay, so this is what I mean by the probability being non-zero. And if you guys also remember, in a normal distribution, we know that x, our normal random variable, can take any value, right? And so a normal random variable, right, is a type of a continuous random variable, and we know that by the definition of a continuous random variable, that the probability that x is equal to some number, right, must equal 0. So that's by the definition of a continuous random variable. Okay. Okay, and so also the probability that our normal random variable, which is a type of continuous random variable, is less than or equal to 3. Okay, must equal to a certain number I, right, which cannot equal 0. Okay, so the probability of an inequality inside, right, must not equal 0, and that's by definition of a continuous random variable. Okay, so let's say, for example, we want to find the probability of x being equal to 3. Okay, and so we know that this is true, that x, our variable, belongs to a binomial distribution, which can be approximated by a normal distribution. Okay, So now we know that the probability of x being equal to 3 cannot be equal to 0 because x belongs to a binomial distribution. Okay, so let's say x denotes the number of heads that we want to achieve in tossing a coin n times. All right, and so we want to find the probability of getting 3 heads. Right, so we know that the probability of getting 3 heads cannot equal to 0 because we know that x belongs to a binomial distribution of np. And so now if we want to find the probability, so let's say we want to find this value, right? Let's say we want to use a second method, right? So remember, the way that we find the probability value is by using 2 methods, right? Sorry, it's by using either one of the 2 methods. Okay, so let's say we choose to use this second method here, the normal approximation. Okay, so let's say we want to use a normal approximation, right? So finding p of x equal to 3 in a normal approximation, right, where it's a normal distribution, right? That means that the probability must equal to 0. Okay, it's equal to 0 because it's in a normal distribution. Okay, where the normal distribution is a type of a continuous random variable, right? So remember this here. Okay, so remember by definition. Okay, in a normal distribution, the probability of x being equal to some number must equal to 0 by definition, right? So what that means now is that we have a contradiction, right? Because we said at the beginning that probability must not equal to 0, right? Due to the formula, okay, the binomial distribution formula. But then at the end, when we use normal approximation method, right, instead of the other method, which is the binomial distribution formula, right? When we use normal approximation method, we said that it's equal to 0. So we got some sort of contradiction here. And so this is what the continuity correction does for us. The continuity correction avoids this contradiction during the normal approximation. Okay, so let me elaborate a bit more on this. So again, let's say we want to find the probability of x, a variable, being equal to 3. Okay, the number of successes being equal to 3. And we know that x belongs to a binomial distribution of np. Alright? And let's say again we want to use the second method, alright, the second method of finding the probability, which is the normal approximation, alright, this second method here, as discussed before. Okay. So firstly, we convert it by approximation into a normal distribution. Okay. And so what the continuity correction does for us, right, is to correct the probability during the conversion in such a way that the probability of x being equal to 3 in a normal distribution cannot equal to 0. Okay? Alright, so this is what the purpose of the continuity correction does for us. Alright guys, I'm going to continue on into the next video.